Okay, I just want to look at factorising over the rational field, over the real field and over the complex field. Okay, so a rational number is basically, I'll put that in there too. A rational number is basically one like that you can write in the form of a over b, where a and b are integers. So basically if you can write it as a fraction, it's rational. So if you're looking at irrational numbers are like root 2, root 3, pi. You can't write those as fractions. They go on forever after the decimal point. They don't repeat, they don't recur. Okay, so just have a think about a complex number can be real, it can be imaginary, or it can be both. Okay, so like 2 plus 3i. The real part would be, you could just have a real number, would be 2 plus 0i. You could have an imaginary, it was like 0 plus 3i. Okay, so if we go into here, real numbers can then be rational. So it just means like a real number that is not a surd, like 2, 3, a half. It can be a fraction, but no surds. So if you're going to factorise something over these different fields, so for example, factorise, now say z squared plus 4, z squared plus 4. Let's just do that for starters. So z squared plus 4, you write that as z squared minus 2i squared. And this can only be factorised over the complex field. It's z minus 2i, z plus 2i. The complex field means that like its factors there, you have the 2i and 2i. They're both imaginary. So it's over the complex field. So it consists of an unreal part. If you had z squared minus 3z minus 18, see that should be z. That would be z minus 6, z plus 3. That is totally over the real field because you have real factors. If you had z squared minus 7, that's the difference of two squares, but you factorise it, that there would be over the real field. They are irrational numbers. By the way, too, these are rational. So this one's over the rational field, and the rational field is also real. So with this one here, you can only factorise it over the real field. Okay, with this one here, you're doing it over the real field, but it's also the rational field. Because the rational field is contained within the real field. Okay, there. So there's a rational, and then if you look out here, there's the real. Okay, and there's the imaginary, and here's your complex number, which contains both of these. So a complex number is real, or it is imaginary, or it could have a real part and an imaginary part. Okay, so now if you're going to factorise, let's just look at this one. So z4 minus 2z squared minus 8, for example. So the first step would be, instead of writing z and z there, you write z squared and z squared. Because when you multiply this, z squared times z squared gives you z to the 4. And here you'd put minus 4 plus 2, because minus 4 times 2 gives you the minus 8. If we do the nose and mouth, that would be minus 4z squared plus 2z squared. Okay, so therefore, if you wanted to do it over the rational field, you could still take the z squared minus 4 and make it z minus 2z plus 2, and both those factors are still rational. So that would be over the rational field. Okay, that one's rational. Let's just wait a minute. We'll just write that next to it. That's rational. All right, then if you want to do it over the real field, the real field would still be the same because I can't really do much more than this. Now this one here, this one can be written as z squared minus root 2i squared. So now we're going to, if we factorise that, we'll end up putting it over the complex field. So it's z minus 2, z plus 2, z minus 2i, z plus 2i. That will be over the complex field. Okay, and a final example, z squared minus 3z minus 18. Now I'm actually going to make it z to the 4 and z squared, so let's check that out. Okay, so that would be z squared minus 6, z squared plus 3, because the product is minus 18, the sum is minus 3, so you're talking 6 times 3, have to be minus 6 plus 3, because we want to get that middle term of minus 3. And see the z squared times the z squared, that will give you, like z squared times z squared, that'll give you z to the 4th. And the other one, the z6 times z3 will give you the minus 18. The middle terms, minus 6z squared plus 3z squared, when you add those together, that's where you get your minus 3z squared. Okay, so now look at these separate factors. That there will be over the rational field, because at the moment they're all rational. If I wanted to do it over the real field, I could actually expand that a bit further and make that z plus root 6, z minus root 6, z plus root 6. And then you just have z squared plus 3. You can't do anything with the z squared plus 3 because it'd have to be a minus to keep it real. Now, when you do it over the complex field, that's when you do a little bit more with this. You make that z squared minus root 3i squared. That one was over the real because they're irrational, therefore it can't be over the rational. So the complex field, that would be z minus root 6, z plus root 6, and then this one will be, let's have a look, z minus root 3i, z plus root 3i, and that would be the factors.